Now we will be solving this problem for, this is from ISI paper 2013. Now you can try this problem yourself now, having seen all the previous videos. I've taught you enough that you can solve this problem on your own. So give it a try and then come back and watch this video. So now, after looking at this equation, two things come to our mind. First, we can try to find GCD of these two terms, or after finding the GCD, you know how to proceed afterwards. Suppose the GCD comes out to be say 1, then we can call this n as x square and this as y square, and then from there on we can do the rest of the calculation. So that's one way we can go for GCD. And what's the other thing that we can do? We can try to get this number on the right hand side, just the number on the right hand side. You can multiply this, open this bracket, do some factorization calculation, whatever, do whatever we can to bring this number or some number on the right hand side, just number, say 101 or something else possible, just numbers here. If we can do that, and of course brackets here or whole squares, whatever, if we can do that, then we are good. And if we can find this its GCD, then also we have seen how to proceed after that. That also takes us to a solution. So let's try to do both of them. Let's try to find GCD, and also let's try to bring this number on the right hand side. First, what should we do first? Let's first find their GCD. Solve this using the method of GCD. Okay, so let's try to find their GCD first. And how do we find the GCD? We say, let's say the GCD of these two numbers is d, and now since d is their GCD, d will now divide n, and d will also now divide n minus 101, and then d will divide their difference, so d will divide 101. From here we get d can be 1 or d can be 101. Since 101 is a prime number, so it has only these two divisors. Now we'll have to take two cases. Let's take case 1. Case 1 is when d is say 101. Now if d is 101 and t divides n, so that n can be written as 101k, then the equation, which is this equation, then becomes, let's first write that equation. What the equation was, this was that equation. This becomes 101k minus 101 s square. Taking 101 common, we get 101 whole square k minus 1. Now you can do it the previous, like how we did previously, bring this 101 whole square here, and since this is integer, this side also has to be integer, and etc etc. And you can also do it this way. Both are actually similar, same things I'm doing in both of these two cases. Since 101 divides this left hand side, so 101 whole square has to divide, let's not take 101 whole square, let's take 101 divides left hand side, so 101 divides L square. Now since 101 is a prime, and if p divides L square, then p has to divide L. So similarly 101 then divides L, so now L can be written as 101 L1. Okay, so from here we can say L is equal to 101 L1. So then proceeding from here, we get 101 whole square k minus 1 multiplied by 101 L1 whole square. This gives us 101 whole square L1 square. We can cancel out this whole square from both the sides here, and we are left with this. and we can clearly see that these are two consecutive numbers, so their GCD will be 1. GCD of any two consecutive numbers is 1. So now we can easily say that this will be a whole square of some number, and this also will be whole square of some number. Since their product is a whole square and their GCD is 1, we can say that. So this then gives us k is x square and k minus 1 is y square. Again, these are two consecutive numbers and both are whole squares. This can only happen when one is 1, the other is 0. So to get that, we get k has to be 1. And what was our n? Our n was 101k, and we have calculated that k is coming out to be 1. So we get n is 101k equals to 101. So in our case 1, when the GCD was 101, we got this solution. This is what we are getting as answer. Now let's look what happens when d is 1. Case 2, when d is 1. So we have now, since the GCD is 1, this I've done multiple times now, we can call n as x square, we can call this as y square. So from here we get n is x square and n minus 101 is y square. Subtracting these two equations, we get x square minus y square 101. From here we get x minus y, x plus y 101. And we can, without loss of generality, we can take x and y as positive numbers. So these are two positive numbers, addition of two positive numbers, and this is subtraction. So this number has to be greater than this number. So we only get, then in that case we only get one case, which is this number has to be 101 and this has to be 1. This the second case, which was this is discarded as this number is smaller and this one is bigger. From here we get x plus y is 101, and we will not take those negative cases like minus this, because we are taking x and y to be positive. Doesn't matter what x and y is, or if we are negative, we'll get still n be a positive quantity. So from here we get x minus y is 1. We add them up, we get 2x 02. From here we get x is 51, and our n was x square. So we get n as x square and x is 51. So n is coming out to be 51 square, which will then come out to be 2601. We can cross check it. Let's check this quickly. Yes, 2601 it's coming out to be. You can check it on your own. This is our second answer. So from case 1 we got n is 101, and from a case 2 we got this. So from here we have two solutions, n is 101 and 2601. These are two solutions. First we try to see what their GCD is. We got GCD can be 1 or 101. Then we looked at these two cases separately. When d is 101, we did calculation, we got n as this, and case 2, when d was 1, we did our calculation and turned out to be 2601. So from these two cases we have these two solutions. Now let's talk about how we would have solved it if we had chosen the method of bringing this number on the right hand side and factorizing the left hand side, that method through which we solved these problems. So let's look at that method now. So here we have again this problem. So what we are interested now is in bringing this digit on the right hand side. So let's see how we can do this. First, let's multiply this. We get now we'll try to make this as a complete square. And how do we do that? Do that this way. Add this on both sides. This is same, these two things are same, and I have added this term on both sides. What does it do? It makes this whole expression into a complete square. It is a complete square of this thing. So from here we can then simplify it. It will become 2n minus 101 whole square 4 L square plus 101 whole square upon 4. From here we can then bring that L square to this side, and we got what we wanted, which is a number on the right hand side, and these two terms can be factorized easily. Write this 4 as 2L whole square. Now we can factorize it very easily. It will become this. (101) whole square. Now our n is positive. It's given to us in the problem. Here n is this natural number, so n is positive, and this L we can also take it to be as positive since it's a whole square. If n was negative, we would be getting the same result. So from here you can see this term has to be greater than this term. The second one is greater than first, because in both these expressions this is same, and in this term we are adding some positive quantity and here we are subtracting, so this one has to be greater. So then we get this as one case and this as second case. We will not have that third case. This we will not have because this term is bigger. Okay, so first let's deal with this one. Where this one takes it says 2n minus let me change the color first. It says 2n minus 101 minus 2l is 1, and 2n minus 101 plus 2l is this. We add them up, we get 4n equals to 101 whole square plus 1 plus 202. If you simplify this, divide this, you will get n is 2601. You can do that on your own, this calculation. And from the second we get 2n minus 101 minus 2l as 101, and 2n minus 101 minus plus 2l again 101. We again add them up, we get 4n minus this as this. So again, if you simplify this, you will get n as 101. So these two again are same solution as we were getting in our previous method, how we using the previous method, and in this method you also got these two solutions. Let's quickly see what we did here. What we did was we first try to convert it into a whole square. This then you can see then we brought this term right inside, we factorize it, and simply how we do it all the time, we see what are the possible cases. These two turned out to be the possible cases, then we solve those cases separately. From one case we got this answer, and the other case we got this answer. So from both methods we are getting two solutions. First is 101 and second is 2601. So you can solve this problem using both of these methods, and there's one more method which I will be discussing in the next video. Now we will be solving this problem 7, and before I solve it, I would like you to give it a try first. I can give you a hint that we have to factorize it. We will I'm telling you this hint of one solution. There can be other solutions using different methods, whatever. So you try this on your own without hearing my hint, which I'm going to give you now. You try this on your own, and if you can't solve it, then come back and hear this hint, which I'm going to give you now. The hint is this. What I did was I tried factorizing it. I brought these terms on the left hand side, kept the number on the right hand side as usual, then tried to see, can it be factorized? It will come out to be a big complicated equation, but you play around with the expressions a bit, see what can be done, observe, and you see this will be factorized. That's the hint I can give you. And once you've tried it, give it a try, then you can look the solutions which I will be presenting to you now. So this is the solution of our last problem, which is problem 7. I'm just going to explain to you how you can come up with this solution on your own. How can you think of factorizing this complicated equation? So this is our question here. It says we have to find again integral solution x and y. So here we are given multiplication of x square plus 1, this. We have to find integral solutions. Okay, so you can read this solution, what I have done here. Now you might be wondering, how can I come up with such a solution on my own? So you see here, first you need a lot of practice of factorizing complicated expressions, and you need a lot of experience of solving complicated equations, factorizing them, how techniques of factorization. And when you will be solving this problem, you'll have to play around with these terms a lot. See what I did here first was I multiplied this. I didn't multiply this. Why? Because I tried multiplying this once, it didn't yield any results. I didn't see any patterns forming after I have expanded this whole expression. First what I did was expanded this whole expression. Nothing useful was coming out. So I played around with it for a while, and what really struck me when how I reached this solution was, the first thing what struck me was I saw this as this thing, x square plus y square, and I saw this expression. So in my mind I calculated that if I get minus 2x from this expression here, and I will have this whole square. This I did that much calculation in my mind. Then I saw this x minus y here. So from here I got an idea in my mind, what if it was forming one big whole square? this whole square, a plus b whole square, and if we expand this we get a square plus b square. Let's take it to minus here, minus 2ab. So for this whole expression to become a complete square, this thing will come minus 2ab. So what if this is a of this whole square and this is b? I can clearly form a square. If this is a, we call it as a. I can form a square when I saw this and this. Then I thought this to myself. Then I thought, what if I could also form this term square? Let's call it b. What if I can form b square? Then I would be done. Then again, I saw this sum x square plus y square plus 1. Then I thought to myself, all I need is minus 2xy now, which I can get from here. So from here, I kind of started seeing the solution, what it could be like. So, and I kept 4 here because as always we want a number on the right hand side. If we can factor, of course. If we can't factor, this number is of no use. So this is how I came up with this solution. You too, if you play around with this, you eventually start to see how it can be factorized using the observation which I just told you. You have to observe it very keenly, and once you do, you can then sort of come up with some sort of maybe this expression could also be factorized in some other way. I don't know, maybe it could be turned into some whole square plus whole square some number. That could also be true. It can maybe. So I did this, and this then resulted into this, and this you can easily solve from here. This is very similar to our problem 1. They're too similar. Just how we solved this problem, we can solve this one. Here you will have to take 2 cases, first with plus 2, then with minus 2, and the rest of that you can do it on your own. I'm leaving it as homework. So this was our problem number 7.